In this video, we'll be looking at Hugging Face spaces and fine-tuning of a pre-trained model. So over the last few days, we've been going through some of the features that are available to everyone with regards to machine learning, and how Hugging Face is making things very easy for everyone to utilize and to learn machine learning techniques and machine learning tools. So today's session would be really about spaces. Spaces is an area within Hugging Face where people publish applications they've developed using machine learning, and it's free to use, and anyone can just go in there and play around and see what they like. And very helpfully, Hugging Face presents spaces of the week. And then the other section that we'll be looking at today would be to do with fine-tuning. And fine-tuning is where you take a pre-trained model and then train it on your own personal data or some customized data so that it responds to your particular queries in the way you want. So for instance, you may have some data sets that the people who created the pre-trained model did not have. So by training this model based on things like maybe your company data, or your business has specific data sets that no one else has access to, you can take a normal model, machine learning model, and train it on your own data, so that when you send it questions via chatbot or via some other interface, the responses are less of hallucinations, but more of the information that's from your own business. So let's get started with the fine-tuning aspect. Right now, so we are looking at something called Colab. So this Colab on the right hand side, and I was speaking whilst the screen was recording. But the first thing to notice is, if you are going to be testing anything to do with fine-tuning or any machine learning, especially in Python, Google has provided an interface they can use to create your notebooks. And your notebooks are nothing but an interface or a page where you can write the code that you're testing. And what I would like to do is begin by testing some of this fine-tuning process. So the way to get to the fine-tuning documentation on Hugging Face would be to go to huggingface.co/docs, and what we're going to fine tune would be a transformer model. So we'll go to transformers, click on there, and then in the tutorial section you have fine tune a pre-trained model. On here you've got the process for fine tuning a model, and you've got three different frameworks you can use. You've got the trainer framework, which is PyTorch based. Then you've got Keras, which is based on TensorFlow, and then you've got something called native PyTorch. There's a couple of videos here that will talk you through what's going on. But the main thing to note is that our training or our fine-tuning exercise will go through these sections here, these code sections here, to go through that whole fine-tuning process. And if you don't have a development variable, then this Colab comes in really handy. So how do we get this to provide us as much screen real estate as we can get? Okay, so let's start a new notebook. So click notebook. Just wait for that to come up. Right, I'm going to call this fine tune. That's okay. So on the left hand side, they've very kindly just broken it down into fairly straightforward segments. Now we need to install some packages for this to work. So for instance, this dataset comes from a Python package, and it's not detailed here what we need to install. So if we click in this section here, let me pick up what we need to run first. So if you have this exclamation mark at the beginning of your line, this then runs a system or an operating system command, or runs it on the operating system shell. So this section will go off and start installing transformers, datasets, evaluate and accelerate. So whilst that's running in the background, let's have a look at what the initial set of codes would be using contains. So before we can fine-tune a pre-trained model, we'd need to download the new datasets that we're going to use, and we'll need to prepare the dataset for training. So essentially what that means is by default, the dataset's prepared by some random people, and all we have would be the datasets, the columns, what they contain, any labels, and using that information, we'd need to change it into the format that the model we're training would accept, and the function that does all of the training would also understand. So the dataset we'll be looking at is this Yelp reviews. It's a fairly standard open source data set. And so as an example of what's contained within the data set, you'd have the label. The label is essentially a description of what each column or each row within the data set is. So for instance, this one here has given us an example of one of the reviews within that data set. So here you can see, if we look at what the review says, it says, my expectations for McDonald's aren't really high, but for one to still fail so spectacularly, that takes something special. So you can get an idea as to what the review is saying, and then they've labeled this review as a 0. So that 0 means, the way I understand it would mean that it's a negative review, and they've given it a label of 0. So each review would have a label, and what we're training is, all right, these are thousands of reviews and we've given them different labels. So after the training is complete, you can then use the fine-tuned model to you pass it a review that you've come up with, or a new review that it hasn't seen before, and you ask it to predict what kind of review that is. So that's what this fine-tuning solution is going to do for us. So it's completed the installation of the transformers datasets, and if accelerate, actually, let's see if we can switch this to a GPU, because the GPU will be much faster for us. Let's use a T4 GPU. You can change runtime and terminate your current session. Are you sure? Yeah. Okay, we'll go for it. Save. So to go through that whole process now, I wonder, okay, so that's going fairly quickly. I don't know if it's, I don't think I need to reinstall this, but if it's already there, it would tell us. So that's all satisfied, so it should be quick. Then if you noticed, after the last one ran, there was a message at the bottom in red. So I'm just waiting for that to come up. Let me start entering the code that will run next. So from datasets, import load underscore dataset. So dataset equals load dataset. So again, Hugging Face has made it easy to load the standard datasets that are available online. So these are publicly available, and without us having to log on to some cloud location or some bucket on the internet, it's they've provided like a solution that we can easily use. So dataset train 100. So I believe that we'll just print the 101st entry within the dataset, if I'm not mistaken. All right, so we didn't get that. Okay, we got that error again. So pips dependency resolver does not currently take into account all packages. All right, so there's something to do with the conflict. So what does it want? So Google requires that, but we might be okay actually with this one. So I'm going to leave it unless I see some errors later. Okay, so let's get started. So if we click the load datasets, so it's loading. You can ignore some of these warnings. So it's downloading the dataset, and it will print the 100th or the 101st entry. So as you can see, this is the review, and that's the label for that review. So that's essentially telling us that each review or each row within the dataset has the text, which is the review itself, and then its label. So what do we do next? Then we need to introduce a tokenizer. So the tokenizer is essentially what converts the text, the review itself, into, it breaks it down into what you might call syllables, and those syllables are the syllables that will be passed into the model for the model to train. So these are the tokens essentially that we use in order to communicate with the model. So it can't take the full sentence. The sentence has to be broken down into different tokens. So that's what our tokenizer would do. Also, the tokenizer would truncate some of the sentences so that they're all uniform. And in some cases, some of these tokenizers can also pad. So if there's a sentence, if we say, for instance, we want a sentence length of 200 characters or 200 tokens, then as the tokenizer is passing through each review, it would either pad them so that they fill up the 200 character length, or it truncates them so that they're reduced to that 200 character length. Right, so let's add this code. I'm not going to type it all out because it would take ages. Right. Okay, so just to run through this. So this is the transformer. We've imported a tokenizer. Then the tokenizer here is loading the Google BERT model. So you can see here it's saying the auto tokenizer, and it's from a pre-trained model. That's the model there. It's also giving us a max length, which is the padding type, and then we're saying that the truncation should truncate. So let's click that. Let's click to run. So as you get the code into your notebook, so notebook is a bit on the right. When you create a code section, just make sure you execute it and go through the process that way. So this one is saying here, this section of code here is saying that you can either reduce the training set, and so that you can reduce the time it will take. Didn't go for that option. Went for the full length. So that might take a while. I don't want to keep talking for ages. Right. I don't quite know how to speed up the video CapCut. Something I need to figure out in the edit. But for now, it's not too slow. So in order to fill in the time, 11% for mapping. So tokenize dataset. So dataset.map tokenize function. Okay. So what's happening in this bit here is, if you recall, we've downloaded all the datasets. So the full review dataset, that's that dataset value, or all of the text within the dataset, is now in this dataset variable. So down here we're now using map. So map essentially just loops through everything within that dataset and applies a function to it, and the function it's applying is this tokenize function. So if you see this as a loop, so for every row within my dataset, do something to it. So as it's looping through, it's passing the row into the tokenized function, and then the tokenized function is looking for the text field. The text field is the review itself, so like this. So that's a review, and then it's either padding or using a padding protocol to pre-process that review, and then it's either truncating or padding. So that's what's happening here. And I'm not sure how long or how many how many rows are in the data set. But okay, just bear with me. You can speed the video up on YouTube when you see it. But so that's what's happening. So once this pre-processing has taken place, we can then train our model. So whilst that's running, let's get the trainer loaded up and running. So for that, we'll just add a code section. We can add a text section as well, so that you see. So you put a hash, and then say maybe the training section. Okay, and then we'll go into the code. I'll just copy this as well. Right, we can't really do anything until the map completes. Right. And then the next section after we've done the training is the parameters training section. So for hyperparameters are the things that you can change within the model as part of the training, so that you influence how the model learns. So as an example, one of the things that you can train is the accuracy. Is it accuracy? Yeah, there are some key parameters that you can change. They're called hyperparameters. So these hyperparameters tend not to be, or hyperparameters are parameters that are not part of the data set itself. So anything that's changed in the model is considered a hyperparameter. And the typical things that tend to be changed are things like the learning rate. So that's how the changes that the model goes through as it's trying to learn. Because typically when the model is learning, it's being presented with data, and then it reviews the data, comes up with the result. If the result is really bad, it will go back and try again and keep going and going. But for each iteration, it's changing how it's learning. So if you adjust the learning rate, you can make the adjustments small or make them large, and that will determine how quickly it would get to the point where you're happy with what it's learned, and then you can stop the learning. So, and you can also change things like the epoch. The epoch is the cycle, the number of cycles that the machine runs through in order to understand the data that you've presented. So think about it like this. You've given the machine learning model the data, and how it learns is by continuously running through that data and essentially guessing the result, predicting or inferring. And when it infers, it compares its result with the actual data, and if they don't match, then you know it hasn't yet learned. So it will keep going and going until it figures out how to arrive at a result from the information you presented. So the things you adjust in order to get it to arrive at a result, those are the hyperparameters. Okay, so what else do we need here? So next, create a training argument class, which will contain all the hyperparameters for activating different training options. Okay, right. So we can start with the default training hyperparameters. If we haven't specified anything we want to change, then it's just going to use a default. Right. Okay, so that's the training section. If we do the training hyperparameters, fine. Put that here. Let's copy that. Oops, there's that. So evaluate means it's essentially evaluating a model to see if how good it is and how well it's learned from the data. and you evaluate by presenting it with information that it's not been trained on. So that's how you validate that what's the model has done is accurate. Okay, so here, compute metrics. So you can call compute on metric, which is this metrics, to calculate the accuracy of the prediction. So the prediction is essentially the model showing you that it's learned what it's supposed to have learned. Okay, so that evaluates, gives us a metric. Right, so let's add that piece of code. Yeah, this is very interesting. So this is essentially how you'd train something, a model that you'd use within your business. Okay, so if you'd like to monitor the evaluation metrics during fine-tuning, specify eval strategy. Okay, this one's epoch. So epoch is the number of cycles around the data. Okay, so let's grab that, put that in here. Right. Then this is where the trainer takes place. So create a trainer object with your model and training and test data sets, and fine-tune your model. Okay, so let's do this. And then with this one, we can just initialize the training function, and then we can kickstart the training itself. So we'll just do this trainer.train. Okay, so it should have finished by now. 68%. Oh, how many times is it doing this? Okay, not sure what it's doing now. But okay, so that's done. I suspect it's doing, anyway, not sure what the second one was about. So that's completed the tokenization of the reviews. So now let's load our model. So we'll download the model and then cache that. Then now we're defining the hyperparameters. So we've gone with the default hyperparameters because we haven't specified anything here. So it just picks the standard hyperparameter set. So here, this section here, these are just standard Python packages that will be loaded, and we're defining what metric will be loaded here, and we're going for the accuracy metric. So in this place, we're just defining what will be used to measure the accuracy. So this function, compute metrics, will be used down here. Okay, so train set. It's going for small train data set, but we didn't go with small train data set. So that's this small train data set. So they're both small train data set. Okay, small eval data set and small train data set. This is referring on the left hand side where so small train data set and small eval data set. Okay, so that's what was happening here. The tokenized data sets. So you've got two items in this. Test and train. All right, okay, so I missed a bit there. Okay, so after the mapping, so it says if you like, you can create a smaller subset of the full data set to fine tune on to reduce the time it takes. Okay, so after the data set has been Right. Okay. So that makes sense. So the small train data sets essentially from the tokenized data sets that we've already gone through, the train. So the tokenized data sets will contain two sets of data. One is train and the other is test, and that's what on the right hand side, when I'm hovering over the variable, it showed us that there are two items within the data set. The train, so it's telling us, giving us a description of this tokenized data set. So it's telling us there are two items. Okay, I'm trying to scroll that. Okay, so two items, one is train and the other is test. So on the left hand side, it's saying that if we want to make things faster, it's just taken the train set of data from the tokenized datasets variable, and it's just selected 1,000 at random, and it's just shuffled, it's just taken 1,000 random and created a train dataset. And then it's done the same for the test. So the test is what you're using to test the model. The train section is what you're using to train the model. So it's taken 1,000 from both, and that should speed things up. So let's do the same, because it seems it might take too long otherwise. So I'm going to recreate that here. It makes sense to do that, so we don't have to wait so long, because we'll get the idea. Right, so let's execute that. Right, so those, yeah, so you can see. Okay. Oops. Okay, so we've done the compute, we've done that, and then we can do the trainer. So the train set and the eval set are from these two, and then now that we've defined the trainer using we've defined the model, which is the Google model, and then we've got the training arguments, which are the standard hyperparameters that we've defined up here in job number 9. And then we've got the train set, which we just created. We've got the eval set, so that's what we'll use to evaluate the model once it's done the training, and then the metrics that we're using, and that's it. So let's click the trainer.train. Now this is where the actual fine-tuning starts to occur, and you're running through an epoch. So if you recall, we defined the epoch as the strategy for the evaluation, so for us to see what is happening as it's running through, and I wonder how many epochs we defined, if that's defined anywhere. Okay, so that would be part of the standard hyperparameters, I suspect, because we've not defined explicitly what the epochs should be. But if we believe what's been declared here, that using this would speed things up, then that's what it is. So okay, so that's really it. So we don't stretch this video for too long, and that's how you can fine-tune a model. So in summary, what you do is you select the model you're going to use as your pre-trained model, so that's the basis for your fine-tuning, and then you get your data set. You prepare the data set using some like the tokenizer function, and you can do all sorts of things with your data. You just need to make sure that it fits in with what you want the model to do. And then you define your hyperparameters, define your training function, and then you pass all of that information into the trainer, and then you set it off to train. So once that's completed, you then have a trained model, and that trained model, as part of the training, would automatically be evaluating the model. So as you can see here, so the first epoch has completed. I'd expect them to be, I'm not sure how many epochs there will be, let me not guess on that, but each epoch will run through and it will tell us what the valuation loss is, and what the accuracy is. So you can see here that it's giving us 1.07 validation loss, and then an accuracy of 0.53. That 0.53 is actually 53%. So an accuracy of 53%. So what that means is that it's run through the data, it's done its initial first cycle through the 1,000 rows. Those 1,000 rows or 1,000 reviews are what we defined here as the small trained data set. So it's trained on those 1,000 reviews, and then it's been automatically tested on 1,000 evaluation rows, and it's only come up with a 53% accuracy. So that's really low. It will go through again, and when it completes the second time, I'd expect the accuracy to go up. And then by the time it completes, actually, so this epoch here is showing me 1.88/3. So I presume there will be 3 epochs. So by the time it completes the third epoch, you should expect it to be a lot more accurate. And we can see that. So the second one is completed, and what's it doing now? It's going through the evaluation. So it's done the initial training. Now it's going through the evaluation piece. So let's wait and see what happens there. Okay. Right. So hopefully it gives us what we're looking for. Right, so it's 58%. 58% is fine, but it's still training. Okay, so we'll let that run in the background. Hopefully we'll come back to it a bit later. But if not, I don't want the video to go on forever. So let's move to the other section of things. The other thing I wanted us to look at was spaces. Whilst that's running around. So this is a Hugging Face feature where people can publish the applications they've built using machine learning. There are thousands of spaces. If we go into the spaces page, so if you go to huggingface.co, you'd have spaces at the top. So you click spaces, and then you can see here different spaces of the week. And you see all the running apps, and it's a case of what do you find interesting, what do you want to play with. I find that I just pick some at random, and they tend to be sort of vision based. But I wonder what else. Okay, we've got voice clone. Let's see what voice clone do. You have to drop audio and upload the audio. Don't they have any examples? Okay, they have this one, right? Okay, so if we play, okay, so if we submit that, so hey, it's me, Dorothy from Wizard of Oz. Type in whatever you'd like me to say. All right, I see. Right, so what this is doing, it's cloning this voice, so this voice, and it's using this to, so if I type in here, this is the best YouTube channel, right? So now if I submit that, on the right hand side, it's going to, cool. So it said the sentence using the voice in this section. So, all right, that's very interesting. So that's voice clone. So that's essentially what's going on here. Now, how you can use this within your business, you have this use via API. So I think that's where the secret sauce comes in. So clicking on use via API, it then tells you how you can use this via the API. You install this Gradio client, and then within your code, you'd want to pass in the voice type you want it to clone, and the text. You pass it the audio file, and then you pass it a type, which would be to predict. I imagine. Okay, right here it tells us what's required. What is it? So text. So the input value that's provided in the text. Okay, could have told us a bit more, but that text is essentially what you want it to come back with, the sentence or that you want it to say, and then the file here, this web file, is the example that you want it to clone, and the API name is essentially the function you want it to complete, and that's it. That's what it seems like. Can't see anything else. So you copy that into your Python code, and then it does it. And you've got a JavaScript option as well. So that's really cool. So that's voice clone. Just make a note of that. So it's called voice clone for Toniasi. Nice. Right, let's have a look at some other spaces as well. Let's see what else is there. So as I've mentioned, you've got this here that I was playing with earlier as a Scribble SDXL. Should we see what else there is? Let me open up another. What's this? Okay, these are for the data sets that we were looking at yesterday. Right, okay. What else should we look at? What's this on Omost? Omost. Is that 0 or is it O? Type a message. What's the message supposed to be doing? So it's a language model. Okay. So the prompt is generate an image of the fierce battle of warriors and the dragon. So let me click that. Okay. To generate an image of the fierce battle of warriors. Trying to figure out what it's doing. Okay. It looks like it's just typing out the instructions. Let's see what it does. Generate an image. There's an image it's supposed to generate of the fierce battle of warriors and the dragon. Is it going to do it? Right, so, oh, that's interesting. So it's generated the okay, so render the image. Just doing that in the background. Atmosphere is chaotic and intense, mirroring. Oh wow. Oh, that's brilliant. That's so cool. Right, so it's this is just fantastic. So so almost canvas equals canvas 0 canvas function. I wonder if this is the HTML5 function that it's doing here. So HTML5 has something called canvas, and canvas tends to be for drawing images, if I recall correctly. So I wonder if that's what it's used here. So it's generated the code that you can use to display essentially this image within your Yeah, I need to see a bit more about this and what it's doing. But this looks brilliant. Look at that. Isn't that amazing? Wow. Okay. Oh dear. You can just nerd out on this for all day. I'm using nerd out, which is Mr. Wolf's. Okay, so let's pick one more. See what else there is. I've seen this Yolov 10. So it's a space of the week. Let's see what this is. Yolov10 Web. So object detection. Oh, I see. Let's try the example. Okay. So you put an image, and then it tries to figure out what's in the image. Nice. Okay, so I suppose you could put any image you want and get it to guess. I don't have any images prepared for this, so we just have to take what it's showing us for face value. So it can tell there's a person in there. It's a car. Yeah, this looks like all those ones you see on TV where for the security cameras are monitoring shopping centers or shopping areas and pointing out what people are doing. Okay, so this, maybe if we just pick one more. Yeah, I think we should just call it there. It's already a long enough video. So hopefully you can see two other functionalities that you can play with in Hugging Face, and these things are made available to you free of charge. And as you can see, the codes to utilize these functionalities are there. You just have to come in here, find what you're interested in, and add that to your solution, to your application. There's also the option to fine-tune a pre-trained model. The steps for doing that are very straightforward, and Hugging Face has made that available to everybody. So thank you so much for joining me on this session. I know it's been a bit long, but we've learned about fine-tuning, and we've also learned about Hugging Face's spaces and applications that we can play with. And there's over 8,000 different spaces. So feel free to come out here and play with whatever you can. So until next time, keep winning.